दिख रहा है मैम?
Yes.
Thank you. Good afternoon, students. Our today's topic is metal displacement reaction. Metal displacement reaction is based on reduction oxidation chemistry. So before going to the details of metal displacement reaction, we shall put a closer view on reduction oxidation reactions. Oxidation is a process which involves the loss of electrons by the atoms or the ions, whereas reduction is a process which involves the gain of electrons by the atoms or the ions. So these are basically reverse process of each other. Now here are some examples. You see that formation of sodium plus, the formation of sodium plus ion from sodium metal, the formation of ferric from ferrous, and formation of chlorine gas from chloride. These are all examples of oxidation reaction. Whereas the reverse process of these three are the examples of reduction reaction, as you can see here in the slides. Now, what is oxidant and what is reductant? Oxidant is oxidizing agent. It oxidizes other substrate and itself reduces to lower oxidation state. Whereas reductant are the reducing agent which reduced other substrate and itself oxidizes to higher oxidation state. You see here one example, magnesium and chlorine are reacting with each other and forming magnesium chloride. In this reaction, metallic magnesium is a reductant and chlorine is an oxidant in this reaction. As I have shown here, the change of oxidation state after the reaction and before the reaction. Oxidation and reaction always taking place simultaneously. Why? Because free electron can't exist in the environment freely. It has no existence in its free state. So always oxidation and reduction are taking place simultaneously. Here one reaction, zinc, metallic zinc is reacting with the copper sulfate solution. So copper sulfate in the aqueous phase and it is solid metallic zinc. They are reacting with each other and forming zinc sulfate and elemental copper. In this reaction, zinc to zinc 2 plus formation is an example of oxidation, whereas copper 2 plus to copper conversion is an example of reduction. So here we have seen that in a reaction, if it is an oxidation reaction, oxidation reduction reaction, then their oxidation and reduction always will be taking place simultaneously. Now, what is redox couple? Redox couple is a combination of oxidant and reductant of the same element which are coupling with each other in a reaction or in a specific state. For example, zinc 2 plus and zinc, they are of same element, but zinc 2 plus is the oxidized form and zinc is the reduced form. So zinc 2 plus and zinc, this combination we can say is a redox couple. Copper, similarly, copper 2 plus copper is an example of redox couple. So redox couple basically the combination of oxidant and reductant of the same element which are participating in a reaction together. Now, electrode potential. When a metal strip dipped into the metal salt solution, there may occur three phenomena due to the collision between the metal electrode and metal ions of the solution. What are these phenomena? First of all, there may occur no change. Secondly, metal strip will be converted to metal ions and will go to the solution, will move to the solution. So solid to aqueous phase. This will be the movement. And it is basically oxidation, metal to metal ion formation. The third possibility is a reverse one, where the metal ions taking electron are converting into metal and deposited over the metal strip. So this is reduction. So these three possibilities are there. Now, among these three possibilities, which will occur and which will be occur, that will depend on their electrode potential value of that metal and metal ions. So इलेक्ट्रोड पोटेंशियल वैल्यू क्या है, इसके बारे में अभी हम लोग डिस्कस करेंगे. It is the measure of potential of the redox couple. So standard electrode potential is the measure of potential of a redox couple under the standard condition of reaction. What is standard condition of reaction? If the reaction is in aqueous phase, then 1 molar concentration of the solution. If it is in the gaseous phase, then 1 atmosphere pressure at 25 degrees centigrade temperature is known as international standard condition. Such potential can be measured of a redox couple by forming an electrochemical cell. That redox couple have to couple with a reference electrode whose electrode potential is already known. Generally, hydrogen electrodes are used to form unknown redox couple to measure the electrode potential of that redox couple. Standard hydrogen electrode का potential value is taken as 0 according to the international convention. What standard hydrogen electrode consists of? Standard hydrogen, it consists of a glass tube containing hydrogen gas of 1 atmosphere pressure, and a platinum electrode is dipped inside of that glass tube into the HCl solution of strength 1 molar concentration. So basically, there is a 1 molar concentration HCl solution, one glass tube is there, that glass tube containing 1 platinum electrode, that is a inert electrode, and hydrogen gas, that glass electrode containing, that glass tube containing 1 hydrogen gas of 1 atmosphere pressure. So basically, this is hydrogen electrode. What is the reaction of this half cell reaction of hydrogen electrode? H plus is taking 1 electron forming hydrogen gas. This is the reaction of hydrogen electrode. According to the international convention, the E0 value, standard electrode potential value of hydrogen electrode is 0 volt. Now, in a electrochemical cell, a unknown redox couple, जिसका हम लोग potential value नहीं जानते हैं, it will couple with this hydrogen electrode, and then we will be able to measure the electrode potential of that unknown redox couple in a electrochemical cell. When the metals are arranged according to their standard electrode potential value, we obtain electrochemical series. So अभी हम लोग metal का standard electrode potential जान गए हैं. We know the electrode potential of different metals. So now we can arrange according to their value. And if we will arrange those metal ions and metal according to their standard electrode potential value, the series we will obtain, that is known as electrochemical series of the metal. Here you see one electrochemical series. This electrochemical series denotes magnesium is here the strongest reducing agent among these 5 metals, whereas silver plus is the strongest oxidizing agent among all these 5 metal ions. Here I have arranged these 5 metals in decreasing order of their reducing power, and also have arranged decreasing order of oxidizing power of these metal ions. So you see, magnesium is here the strongest reducing one, and silver metal is the weakest reducing one. In between magnesium and silver, there is zinc, lead, and copper accordingly. Whereas in case of oxidizing power, you see, silver plus is the strongest oxidizing agent, and then gradually the oxidizing power is decreasing, and magnesium 2 plus is the weakest oxidizing agent among these 5 metals. Now we are moving to metal displacement reaction, as we have a good idea about reduction oxidation chemistry. In this reaction, you see, AB is a ionic aqueous salt, where A plus is a metal ion and B minus is corresponding anion. It is totally soluble in water. It is ionic compound and aqueous salt. C is a elemental state, and C is particularly a metal. AB is reacting with C. It is forming Cb, that is also a ionic salt, and A, elemental A. In this reaction, it is a metal displacement reaction. Why? As C has displaces A plus from the salt. From the aqueous salt, C has displaces A plus, and that's why it is a metal displacement reaction. Now, minute observation, you will see that it is also a reduction oxidation reaction. As A plus has converted to A, so it is a reduction reaction, and C metal has been oxidized to C plus. So we can conclude that metal displacement reaction is nothing but a reduction oxidation reaction. Here, in a tabular form, you can see the ability of the different metals towards displacement reaction. We have taken 5 nitrate salt, magnesium nitrate, zinc nitrate, lead nitrate, copper nitrate, and silver nitrate. Okay, so 5 nitrates and 5 zinc, lead. Now we have to check which metal can displace which metal ions in their aqueous saltic form. एक्वास सॉल्ट फॉर्म में जब मेटल आयंस है उसको कौन सा मेटल डिस्प्लेस कर सकता है और कौन सा मेटल डिस्प्लेस नहीं कर सकता है, ये हम लोग चेक करेंगे. नाउ यू सी द ग्रीन कलर पॉजिटिव साइन डिनोट्स positive result. The negative sign in red color denotes negative result, that is displacement not possible, displacement not occur. And black cross denotes experiment will not be performed, as these are similar metal and metal ions. You see, magnesium metal being the most strongest reducing one, it can displaces all 4 metal ions, zinc, lead, copper, and silver from their nitrate salt. And silver being the weakest reducing agent, silver is not able to displace any of the metal salt from their corresponding aqueous nitrate form. The other metal like zinc, lead, and copper are in between position. So थियोरेटिकली हम लोग मेटल डिस्प्लेसमेंट रिएक्शंस के बारे में अभी जान गए हैं और इनका एबिलिटी भी जान गए कि कौन सा मेटल कितना कैपेबल है टू डिस्प्लेसेस अदर मेटल्स फ्रॉम देयर आयनिक सॉल्ट. नाउ these things we shall determine, we shall observe in experiments. So first thing is that we have prepared 50 ml 0.1 molar solution of each nitrate salt like magnesium nitrate, zinc nitrate, lead nitrate and copper nitrate. For that, we have to calculate how much gram amount is required for this preparation, because we have to weigh that gram amount and then we have to add with 50 ml of water and then mixed up to prepare the solution. So 50 ml 0.1 molar solution means what gram amount? Molecular weight of that particular nitrate salt into 50 into 0.1 by 1000. Molecular weight of that nitrate salt into volume into strength by 1000. That gram amount in each case is the requirement to prepare the solution. In case of silver nitrate, as silver is unit positive charge ion, so we shall prepare double strength of the silver nitrate. So in case of silver nitrate, we shall prepare 50 ml 0.2 molar solution of silver nitrate. So what will be the calculation? How much gram amount of silver nitrate is required? Molecular weight of silver nitrate into 50 into 0.2 divided by 1000. That gram amount of silver nitrate is required to prepare the solution. Now we shall take a brief idea about the apparatus required for this preparation of the solution. The first one is the graduated measuring cylinder to measure the volume of water. The second one is the distilled water bottle. Squeeze bottle is also, इसका नाम squeeze bottle भी है, distilled water contain करता है ये. The third one is the solid sample containing glass bottles or glass jar. Is the watch glass to weigh the solid sample. Fifth one is the digital balance, that is also to weigh the exact weight of the sample. And the last one is the funnel and earthenware flask to prepare the solution. Now, with the help of digital balance, watch glass and spatula, spatula is a spoon type of things, we have to weigh the exact amount of the nitrate salt in each case, whatever we have calculated as we seen in the previous slide, in a watch glass. And also we have to measure the volume of 50 ml of water in a graduated cylinder. Then both of these solid and liquid we shall carefully add it to a earthenware flask with the help of a funnel, and then mixed up wells form. Now you see 50 nitrate and 50 ml 0.2 molar silver nitrate. Among these 5 solutions, copper nitrate is bluish green in color, whereas the other 4 are colorless. Now in the second part of the calculation, we calculate how much mole amount is present in each of these solution. कितने amount mole present है, कितने gram amount present है, वो तो हम लोग को मिल गया है, उसी के मदद से हम लोग solution बनाए हैं. Mole कैसे calculate करेंगे? If we know the gram amount, mole is very easy to calculate. Volume into strength by 1000. 50 is the volume by 1000. That means where we have prepared 50 ml 0.1 mole magnesium nitrate is equals to 0.005 mole of magnesium nitrate. Similarly, zinc nitrate, that is also equals to 0.005 mole. Lead nitrate, that is also equals to 0.005 mole. And copper nitrate, that is also equals to 0.005 mole. As in case of silver nitrate, double strength solution we have prepared. That is 50 ml 0.2 हिसाब से मोल भी चेंज हो जाएगा. 50 into 0.2 divided by 1000, that is 0.01 among these 5. Calculated this mole amount. In our next slide, we commence our experiment. For our first experiment, we have chosen copper nitrate and magnesium solid. Why we have chosen copper nitrate? As copper nitrate have a specific color, so observation of the color change will be easier for us. So the first experiment, in the 50 ml 0.1 mole copper nitrate solution, we shall add solid magnesium metal to observe whether any displacement reaction is occurring or not. What about the change? What is the observation? That we will check now. Each of these are reacting with each other in one equivalent amount. So 0.005 mole of copper nitrate will be able to react with 0.005 mole of magnesium solid. Molecular weight of magnesium is 24.30. So multiplying molecular weight with mole, we shall get the what exact amount of weight we have to weigh to add to the copper nitrate solution for the full reaction. Complete reaction होने के लिए कितना amount, कितना ग्राम amount magnesium चाहिए. Okay. And multiplying 0.005 with 24.30, we obtain 0.12 gram. So 0.12 gram we have to weigh with the help of watch glass, digital balance, and spatula, and that we have to add very consciously with the help of funnel to the flask containing copper nitrate, which have initially bluish green in color. At once we shall add this magnesium, we will observe a very nice observation. The color will totally disappear. It was bluish green, it is now colorless, totally colorless. So this is the observation of our first experiment. Before going to the explanation, we will move to the another discuss the observation. What is our second experiment? The second experiment is just opposite experiment of the first one. यहाँ पे हम लोग मैग्नीशियम नाइट्रेट का एक्वा सॉल्यूशन लिया है एंड सॉलिड कॉपर डस्ट मेटल लिए हैं. सो इट इज जस्ट ऑपोजिट ऑफ फर्स्ट. फर्स्ट में देखिए, फर्स्ट में हम लोग कॉपर नाइट्रेट का एक्वा सॉल्यूशन लिए थे, उसमें सॉलिड मैग्नीशियम ऐड किए थे. यहाँ पे हम लोग मैग्नीशियम नाइट्रेट का एक्वा सॉल्यूशन लिए हैं, उसमें सॉलिड कॉपर ऐड किए हैं. Here also each of the substrate are reacting with each other in one equivalent amount. So 0.005 mole of magnesium nitrate would be able to react with 0.005 mole of solid copper. Multiplying 0.005 with the molecular weight of copper, that is 63.54, we will obtain 0.31 gram. So for full reaction, we have to add to the 50 ml colorless. So with the help of spatula, watch glass, and digital balance, we shall weigh the exact 0.31 gram of solid copper powder, and very carefully with the help of funnel, we shall add that amount to the funnel, and it will be to the flask. In the flask, there was colorless magnesium nitrate. After addition of solid copper, we will observe that there will be no color change. As it was colorless, it is remain colorless. कोई change, कोई color का change, कोई other change कुछ भी observe नहीं हुआ. So it looks like there is no reaction. Now we shall explain the both reaction. Here is the summary of these two reactions. In the first reaction, we have seen color change from bluish green to colorless. It is because of the metal displacement reaction. Magnesium being a stronger reducing agent, quite capable to displace copper 2 plus from aqueous ionic form into elemental copper. And magnesium itself oxidizes to magnesium 2 plus and form magnesium nitrate. This aqueous magnesium nitrate is colorless. That's why color has been changed totally bluish green to colorless. In the second reaction, copper is not so much stronger reducing agent according to their electrochemical series value. You see the position of copper in this series. Copper is in the below position. Then magnesium, zinc, lead, even hydrogen. So copper is weaker reducing agent and not able to displace magnesium 2 plus from its aqueous ionic solution. And thus there was no reaction, no displacement reaction was observed. So this observation is quite similar and can be explainable from our findings of electrochemical series. इलेक्ट्रोकेमिकल सीरीज हम लोगों को जो जीरो वैल्यू मिला था, इलेक्ट्रोड पोटेंशियल वैल्यू मिला था, उसके साथ ये ऑब्जर्वेशन बहुत ही रिलेट किया जा सकता है एंड एक्सप्लेन किया जा सकता है. Now we shall explain about nice application, you can say, about it is a very nice thing. Copper coin into silver coin. How we can do this? The copper coins are. So we have to take silver nitrate is colorless. So in this silver nitrate solution, you have to dip a copper coin. At once copper coin will be dipped, you will observe the solution to blue color. It was colorless. Another of which is inside the copper coin, which is inside the liquid, that is giving, it is giving a white like a silver. Why? Displacement reaction. Reducing agent and silver. Silver is in the below position of the copper. Copper is in the above position. We know above position में जिसका जो metals है उसका reduce करने का ability भी उतना ज़्यादा है. So copper is more reducing than silver. So when copper coin will be dipped inside the silver nitrate solution, what copper will do? Copper, elemental copper will be converted to copper 2 plus. So coin was containing metallic copper, it will be converted to copper 2 plus. And it will form copper 9 as it displaces silver plus from the solution, placing silver in the solution. So it is a metal displacement reaction. As copper nitrate is gradually forming and it is bluish in color, so the liquid of the flask is changing its color from colorless to bluish green. Parallelly, another reaction is taking place. What is that? That is, silver is reduced to elemental silver. Silver was in +1 oxidation state in silver nitrate. Now it is converting into elemental silver. This elemental metallic silver is depositing over the copper coin and giving one white shining appearance. And thus, it will seem in our eyes that copper coin is gradually converting to silver coin. So it is a very interesting application of metal displacement reaction. Now we shall go to the our virtual lab platform. First of all, we will open the VLab application window and click on the file menu in the left hand corner and load homework. Lab setup dialog box will be open. Then open Redox folder and double click on the Redox reaction series. You will get the stockroom explorer in the left hand side and all metals are there. In that stockroom explorer, there is metal displacement reaction and all 5 solid metals are there: silver, copper, zinc, lead, and magnesium. And solution: copper nitrate, zinc nitrate, lead nitrate, silver nitrate, magnesium nitrate, all are in their appropriate strength are present. Okay. Then what you have to do? में हम लोगों को जो मिलेगा. At first we shall choose workbench 1. We have, and there in the workbench 1 we shall and right click on after clicking on the right click on the problem description and we have to type magnesium reaction. Okay, so now we have to choose from the stockroom explorer. Magnesium we shall choose. Then we have 1 molar copper nitrate, 0.1 molar zinc nitrate solution. Each are containing by the glass bottle, 0.1 molar lead nitrate, 0.2 molar silver nitrate. And then click on the glassware menu. And 4 flask we shall obtain. You see here 4 flask is there. Among these 4 solution is blue is 4 flask. What we have chosen, we have to rename this flask by typing. By typing, we have to rename this flask. Then we have to pour the liquid into the flask. As we have now 4 flasks, 1 is zinc, 1 lead, 1 silver and copper. Then according to their name, we shall pour 1 solution into their specific flask. इसमें जिंक लिखे हैं वहां पे जिंक नाइट्रेट डालेंगे. And for this addition, what mode we have to take? We have to precise transfer mode we have to adopt. Okay. By clicking on each flask, we shall get the concentration of the ion in the right hand side. In the right hand side, you see, we shall obtain the concentration of each flask. As everything is in liquid phase this time, you will get only concentration of the ions in aqueous part, not in the solid part. So click on the aqueous version. Now solid magnesium metal we will add to the copper nitrate containing flux. By adapting precise transfer mode, what we will obtain? We will see that color has totally changed. You see, this is bluish green in color, and now you see the change of the color containing the copper nitrate containing flask. It was bluish green. The last flask you see, it is bluish green, and now you see it is colorless. Another thing we have to observe. You see, before addition, the temperature in the right hand side was 25 degrees centigrade. It was 25 degrees centigrade before addition, the temperature of the liquid of the flask. After the addition, you see, the temperature is 29.8. So temperature is increased. Means the reaction is exothermic. So metal displacement reaction is exothermic in nature. That point we have to remember. Okay, heat is evolved during the reaction. Another thing you see, when nothing has been added, तब क्या हुआ था? Everything was in the aqueous part. The concentration of copper 2 plus, you can see the concentration of copper 2 plus, which was in aqueous part, and concentration of the nitrate. It was a positive value. Concentration of copper 2 plus was positive value, giving positive value. See in the right hand side. Now you see concentration of copper 2 plus in the aqueous phase is 0. You see in the right hand side. Concentration of copper 2 plus in aqueous phase, it is 0. Whether in previous case, you see only copper 2 plus metal ion was present. There was no other metal was present before addition. कोई other metal present नहीं था aqueous part में. Now you see, in aqueous part there is magnesium 2 plus is present. Magnesium 2 plus. So we can say that magnesium from metallic form has been converted to magnesium 2 plus, which is the oxidation reaction. Magnesium to magnesium 2 plus is the oxidation reaction. Whereas copper 2 plus missing है, वो कहाँ गया है? वो हम लोग को देखना है. Copper 2 plus नहीं है, 0 है. So now we shall click on the another radio solid button. Solid radio button पे हम लोग क्लिक करेंगे. Aqueous के just adjacent position में solid button का position है. So we have to click on the solid radio button and click करके देखिए अभी क्या है. Copper इन्हें मेटालिक और इन्हें एलिमेंटल फॉर्म, मेटल रिएक्शन को accordingly you can do all the stockroom explorer bromide 0.1 molar सकते हैं. That is determined. You have iodine, you have present. So in between strongest oxidized, bromine is in between weakest reducing agent. Okay. So you have to find out the fate of this reaction. Your clue is the oxidation. Your clue is the electrode potential value. Now I want to acknowledge IQAC team in College Patna for giving me opportunity to demonstrate the experiment